All right, our goal today, as you can see, we want to be able to approximate trigonometric functions using a calculator. Those are be our non-exact values. Find exact values of our trig functions in radian equivalents. So we need to introduce what a radian is. Convert angle measures from radians to degrees and degrees to radians. And then use properties of our unit circles to find trigonometric values that are in radians. So the key today will be to find out what a radian actually is. So let's look at this portion of our work. The radian is a measure created so that the arc length measure and the arc use the same number. So now for most people they're saying, well, what are you talking about? Well, let's go to our circle. And if we had a circle here of radius r, we know that the area of the circle is measured in circumference, or not the area, sorry, the perimeter, and that's the outside edge only. So if we had a wedge here and we had an angle, we want that angle measure to be related. And so if it's related and we want that arc length, which represents this distance here, then we would say circumference equals pi times d, pi times 2r. And since we have radius here, so let's go pi times 2r. So if that's our statement, and you look at that, and we know, oh, okay, I got my radius, my unit circle is 1. So we would be able to say fairly surely that one full circle is 2 pi. Well, if one full circle is 2 pi, then that means 180 is pi, half of that. Knowing we can do that, we can convert any number of radians, degrees, back and forth from one system to the other with that very simple conversion factor. Pi radians equals 180 degrees. We're going to do that later. So if you're thinking, well, wait a minute, okay? So if we've got our 4 quadrants there, and if this is pi, which is 1 pi, and this is 0 pi, or if we go all the way around, we could say it's 2 pi. We're going to have some other values in there along the way, especially at our 30s, 60s, 45s that we haven't really marked up yet. Okay, now some people say, well, what does a radian really equal? Well, remember, if you've got pi radians equals 180 degrees, let's go ahead and divide by pi to find out what 1 radian would be. Go ahead and do that. You should be in the range of about 57 degrees is equivalent to 1 radian. So be careful. How do I remember when I convert from radians to degrees? Notice it says radians to degrees. So what you want to keep is the piece that stays on top. So it's 180 over pi radians when I want to keep it in degree measure, and it's pi radians over 180 degrees when I want to keep it in radian measure. So let's do a couple, just converting. If you take 120, I'll do one, then you can pick another one to do. If we do 120, and notice it says we're going to radians, so that means I am going to multiply by that pi radians over 180 degrees. Now think of this like a normal fraction, and you've got your canceling capabilities that you can use here, and that's the nice part. So if we cancel, I'm going to cancel my 0 on each. I'm going to say, well, 12 and 18 have a common factor of 6. So right now it looks like we have left 2, undo that, I don't know what that was, 2/3 pi radians. You could also write it as 2 pi over 3. They're exactly the same thing. Okay, they're our equivalent. So pick another one out here and turn these degrees into radians. Again, with fractions, you should be able to do some canceling quite nicely. And when you do, as we said here, check your results. If you have any questions on any of those, we'll be glad to talk to you. Notice that the pi is going to stay in it. Yes, you probably should say radians to put your units down there, but the pi is your clue that you still are in radian measure. You don't see a pi when you're in degree measure. All right, let's go the other way. What if I gave you something in radians and you have to convert to degrees? Well, just like we said, we want to take and keep the degrees on top this time over that pi radians. So again, do your canceling. We got a pi with a pi. In this case, 6 does go into 6 once. 6 also goes into 180 3 times. So that leaves top times top, bottom times bottom. So it looks like our answer here is 210 degrees. Now you will find that some of them cancel better than others due to the multiples and factors that go into each other, but that's just sort of the luck of the draw. 210, 225, 720, and 240. We will expect to do a couple of these in class as well. Now, evaluate on your calculator. If you haven't ever seen it, on your calculator you have a mode switch right next to the second key. If you hit that mode switch, you should be able to go to the third row down, and it should say radians and degrees. Now, because we have been basically mostly working in geometry and the first part of algebra in degrees, nothing has been wrong. But right now, these are definitely in radian measure. So we want to have our calculator in radians, so go to that mode now and change your calculator to radians. Go back, and example, we want the cosine. So we'll hit the cosine button just like normal. Your pi button, make sure you use the whole thing, pi divided by 6. That goes in parentheses. We hit equals, and we're looking at a 0.866-ish if we go to the nearest thousandths. So we would do this just like we entered them before on our calculator in degrees, but now they're in radians. So look real carefully. It's obvious I'm in radians, I'm in radians, I'm in radians. This guy, some people would say, hey, is that degrees or is that radians? When you don't see a little degree mark, you have to assume it's in radians. And the reason is someone has already gone through and multiplied the pi out. And it came out to, just coincidentally, a whole number of 6. Can that happen? Sure. Okay. So make sure you put that in radians. And again, to the nearest probably thousandths, which is I have most of these, you're going to see your values. Now, it will be up to you from here on out to make sure you are putting the mode on your calculator according to what you're in. All right. Now, your last little piece is go ahead and now label this in radians. You have your degrees, but if you can do the conversions, you should be able to draw one that has radians. So these are the same wedges. All the red wedges are your multiples of 30s, 30, 60, 90, 120, 150, etc. All the blues are the 45s. So you should be able to give me all of the labels of what they would be in radian measure. So we're looking for that when you come to class. We'll check it. You definitely should have a unit circle that has both. All right, that's all for now.